So now we do this is the end of chapter 9 for us. We just do these 4 sections. The first 2 were arithmetic and geometric sequences. Now we do arithmetic and geometric series. So we'll review this at the end, and hopefully it'll make more sense. Right? So a sequence, as we said in the last one, is an ordered list of numbers. A series is the sum of a sequence. So if you take the terms in the sequence and you add them up, that's a series. Okay. Right, so sequence, series. Now notice we had 2 kinds of sequences. We had finite and arithmetic. Finite and infinite. Finite means you just have a certain number of terms. Infinite means it goes on forever. Dot, dot, dot. That means whatever this pattern is, just assume it just keeps going like that forever. So if you add them up, you're going to have either a finite series or an infinite series. Okay. If you have a finite series, you can add them up. I mean, especially like in this one here, that's a pretty small number of numbers, right? You could add that up quickly. And sometimes that's what we do. If we're given a problem to evaluate, a series to evaluate, you just write down the terms and add them up. How about infinite series? Could you add up an infinite number of terms and get a number? I mean, every time in an arithmetic sequence is or series, which is what we're doing first, every time you add one more term, you just change the sum. So it doesn't make any sense to add up an infinite arithmetic series. But a finite series, that you can do. That's good. Okay. So we have a formula for the sum of a finite arithmetic series. And this is it right here. The capital S stands for sum. Right? The fact that it has a subscript of n means you're going to be adding up a finite number of terms here. Then let's look at the things that are inside the formula here. The A1 represents first term, so we need to know the first term. Right? The n is the number of terms. And the a sub n, which is what we understand to be the formula for the nth term, in this case is going to be the last term. Right? If we're adding up, if we want to find S10, then A10 is the last term in the sequence. So this is first term, this is the last term. What's that? It's to be the last term in the sequence of numbers that you're adding up. Now, if I gave you a true-false question, said true or false, if all you know is the first term and the last term of a finite arithmetic sequence or series, you can find the sum. If all you know is the first term and the last term, can you add up the terms? Or are you missing something? You don't know the number of terms, right? You can't add them up because you don't know the number of terms. It's not enough just to know the first term and the last term. You've got to know the number of terms. So let's try to use this formula. What is the sum of the even integers from 2 to 100? Okay, well, let's see. I've got the formula here already, which I would always write down the formula first. How many even integers are there going to be from 2 to 100? What's the number of terms? It should be 50, right? If you start counting by twos from 2 to 100, n equals 50. Go ahead. Got pass? Up here. Bring them up here.
What is it on the fusion independent E for excuse?
What's that?
It's supposed to be tardy excuse.
Okay. Noted. They've already entered it in the system. Okay. What is the first term? All right, the first term is going to be 2, so there's a 1. And if it's the even integers, well, sorry, that doesn't matter. What is the last term? 100. So this is a n. It pass? Up here. All right, so you have everything you need to plug in the formula. So just plug in the formula. S, 50, because we're adding up 50 terms, is 50 divided by 2 times 2 plus 100. $25 times 102. $25 times 102. 25.50. These are the kind of questions you get on an SAT test, where they'll say something like, add up the odd integers, the positive odd integers between 0 and 200, right? And then you'd have to say, okay, first term is 1, last term is 199. Figure out how many terms you've got and add them up. I mean, they would really expect that you knew this formula, although they don't give it to you. And they definitely think that you understand the word integer, right? If you didn't understand the word integer, then you're in trouble. So you try to do the same thing for this one. This is your you try. Anybody got an answer? Later. Who's got an answer? Deshaun? Say again? 1,030? Somebody got 1,030. I think it's 1,030, right? So in this, the first term was there, the last term is there, the number of terms is there. So just plug in those three things into this formula. Right? S20 equals 20 over 2 times 4 plus 99. 10 times 103, which is 1030. And the truth is, the problem in the book, they didn't actually tell you how many terms it was. Right? All they told you was the sequence right there. So how were you supposed to figure out how many terms there were so you could plug it into the formula? You would have to do this. You would have to say, well, if this is the last term, then using the formula for A sub n, right, I would say A sub n equals 99 equals the first term, 4, plus n minus 1 times the d is 5, and then solve that for n to tell you which term in the sequence it is. To me, that's good. That's kind of early on in the section to be asking that kind of question, that there ought to be a few where you've got all the pieces and you can plug them in. But that is the way it is. I added the 20 terms because I didn't want us to have to calculate that. So you would have to use the formula for AN. You have passed? Put it up here. Okay. Now, what if you have a sequence like this? You want to add up the first 20 so you know what the n is. You could see the first term and you could see the common difference, but you don't know the last term. Right? How would you add that up? And the answer is, right, we're going to use our formula. Sn equals n over 2 times a1 plus an. Now, we know the n and we know the a1, but we don't know the a20. So we use the formula for a sub n. Right? So a20 is the first term, 1, plus 20 minus 1 times the common difference of 4. So A20 equals 1 plus 19 times 4. A20 equals 76 plus 1, 77. So now you know everything you need to plug into the formula. Right? If they don't give you the last term, you have to figure the last term to plug in. And that's why you use this formula. So now we plug in S20 equals n over 2, 20 over 2, times first term of 1, last term 77.
This is the same problem, right?
No. It's a different problem. The 20 is the same. The sequence is not the same. What's that? This was not. Okay, next. Okay. Now, what's new about this stuff, if it was just about that formula, I'd say this lesson is not that hard, but this is a new notation that you're not familiar with. And it goes by two different names, summation notation or sigma notation. Right? And the sigma is because of this symbol right there, which is the capital Greek letter sigma. Now, if you notice what I've got written here, it says it's the sigma. It says n equals 1 on the bottom and 5 on the top, and it has an n squared in the middle of it. And I'm saying it equals 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. I mean, can we kind of imagine how this thing functions by looking at that? N equals 1 to 5. How many terms do you have? You got 5 terms. each one of those terms is 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. Okay, where do you think that came from? From the formula, n squared. Right? We're just plugging in those numbers 1 to 5 in a row and adding them up. So when in terms of the sigma or summation notation, the n this is here is called the index. The number that's on the bottom is called the lower limit. The number that's on the top is called the upper limit. And whatever is in there is a formula for the nth term. That's the an. Now, is that an arithmetic sequence? I mean, if you look at these numbers here, 1, 4, 9, 16, 25, no, it's not. This does not have to be any particular, pattern that we recognize. We only know 2 so far, right? We know arithmetic and geometric. It doesn't have to be either one. Sometimes it is, but it doesn't have to be. Remember that if it's arithmetic, then whatever this formula is, it kind of looks linear. It should look mx plus b, right? Instead of mx, it'll be mn plus b. Right? It'll have an n to the first power. This n squared, that's not going to ever be arithmetic. So that's how we use the sigma notation. It's just telling you to make as many terms as you would get by plugging in the bottom number and then going up by 1 until you get to the top number, plugging in every time for n, the index in the formula. So that is a new notation. That's why I put the series up here. That's why I put that in place of the S. So what is the summation notation for this series? Okay, let's see. So in order for us to make a summation notation out of this, right, first I'm going to need my sigma. And most of the time I'm just going to do something like that, right? And I'm going to need to know, I'm going to say I'll use n as the index, but I need to know a lower limit, an upper limit, and a formula for the nth term. Okay. Well, let's say we start with 1. Okay, that'll be our starting point, will be with 1. In order to know this, we need to know how many terms are there. Because we have to start making terms somewhere. I mean, you don't have to start with 1, but I'm just going to say, let's just start with 1, and then we'll go from there. In order to know what number goes up here, we need to know how many terms are there in this sequence. Okay, do you recognize this as an arithmetic sequence? 7 plus 11 plus 15. It looks like it is. We keep adding 4. So we are going to use that formula for an. Right? That's what we'll use for the formula, and that's what we'll use to find which term in the sequence is that. So let's see. an equals a1 plus n minus 1 times d. Okay. Plug in for the a1. Plug in for the d. Solve or simplify. 7 plus 4n minus 4. an equals 4n plus 3. Okay, that's what's going to go here, 4n plus 3. Okay, now in order to find the n, or the upper limit that's on top, we need to set that equal to 207 and solve for n. Right? If 4n plus 3 equals 207, yes. Sorry, that's your seat. That's your seat. Do not move. Okay, you have a detention today. Okay? Do not disrupt. You understand? No, you may not. Okay. Okay, sit there, but you got a detention. Look, the room is big. Everybody sits somewhere, and you're the one kid who can't sit because you're... Yeah, you're disruptive. Okay, so solve for the n here. Divide by 4, n equals 51. So that's the number that goes on top. Right? So we started at 1. I mean, you should always check. Just make sure that when you plug in, you're getting what you expect. Like if I put in a 1 here, 4 times 1 plus 3, that's the 7. So I got what I need. If I plug in the 51, 4 times 51 is 204 plus 3, 207. So my formula works. And then I need to just make sure I'm generating enough terms. And that's the 1 to 51. That's why we did this right here. To me, that's like the highest level of a question like this, which is that when you don't really know the number of terms, then you're going to have to find that separately. Hurry up. Okay. So same thing. Try to make the summation notation for this. Again, this is the part that you know already, right? You're gonna have a sigma. It's gonna have n equals 1 on the bottom. You need to find two things. What's the formula for an? Right? And you should be able to tell that by looking at this. You can see the first term, you can see the common difference. And then you have to figure out what number goes on the top. Right? You can come up with the an. Remember, you're plugging into this formula, a1 plus n minus 1 times d. You can see both the a1 and the d just by looking at that sequence. Plug them in. Simplify. What was the formula? Anybody? Anybody get that formula? So that's what goes here. 7n minus 12. And then how do we know what number to put here? Set it equal to this last term, right? 268 equals 7n minus 12. So 7n equals 280. N equals 40. 40. Again, you can check, plug in the bottom number, 7 times 1 minus 12, negative 5. Plug in the top number, 7 times 40, 280 minus 12, 268. So it looks like it works. Okay. So now they're giving us the sigma notation and asking for the sum. So again, at this point we have this formula. Sn equals n over 2 times a1 plus an. Right? We need to know three things to plug into that formula, and we got to be able to tell them by looking at the sigma notation. Right? First, how can you tell how many terms you're going to generate if it goes n equals 1 to 70? How many terms is that going to be? Looks like it'll be 70 terms, right? If it starts at 1 and it goes to 70, that's 70. So n equals 70. Okay. How is it that we would generate the first term if we're using that formula? I mean, if I was going to turn these into actual terms, what would I do first? I would plug in the lower limit, right? So plug in n equals 1. What number do you get? 5 times 1 plus 3 equals 8, right? That's your A1. The first term is whatever you get when you plug in the lower limit. And the last term will be, right? This is the first term. This is the last term. So 5 times 70 plus 3, 353. Right, that's the AN. So now you know everything you need to plug into that formula right there. So plug them in. S70 equals 70 over 2 times. First term is 8. Last term is 353. So 35 times 361. So 12,365. Now again, you're given this formula, right? On the SOLs, and on our test, you'll be given the formula. You just have to know, how you're supposed to use it. If you have this, you can just have to know, where am I going to get the three things I need to plug into that, right? These are telling you the number of terms. This is telling you the first term. That's telling you the last term. So try to do the same. Well, no, this is not a you try. Is this, if I generate the terms here, is that going to be arithmetic? Meaning, remember what the formula looks like if it's arithmetic. It looks like it's mx plus b. It looks like it's linear. Is that linear? I mean, that squared there tells you right away, this is not going to be arithmetic. If you get something like that, you just have to make the terms. I mean, plug in n equals 1, and then 2, and then 3, and then 4, all the way up to 7, and add them up. They can't really ask you to do that very well unless it's a small number of terms, but you can get that. So don't try to plug it into the formula for Sn, because it wouldn't work, because it's not arithmetic. Just make the terms. So this one would be, the first term will be what I get when I plug in n equals 1, right? 1 minus 1 squared plus 2 minus 1 squared plus 3 minus 1 squared plus 4 minus 1 squared plus 5 minus 1 squared plus 6 minus 1 squared, started at 1, ends at 7, plus 7 minus 1 squared. And then simplify, right? This is 0 squared plus 1 squared plus 2 squared. Which is 0 plus 1 plus 4 plus 9 plus 16 plus 25 plus 36. And that you can just put in the calculator and see what you get. I think it's 81, isn't it? Let's see. These are 41, 50, 55 plus 36, 91. Right, so because this, not arithmetic. Right, which means don't try to use the formula. Okay, this is one you definitely can use the formula on. Right? Again, you're going to plug in in this formula, Sn, n over 2, a1 plus an. So you're going to have to determine the number of terms, the first term and the last term, plug them in, calculate. First term is anybody got an answer? That one, Caitlin? What'd you get? 2,140? Who else got that? Anybody? That is right. 2,140. Right. What was the number of terms that you plug in? Right. Starts at 1, ends at 40. That's obviously 40. You know, when those things get trickier is when you have something like the sum from n equals 3 to 8. How many terms is that? It's not 8 because you didn't start at 1, right? So you got to be careful. If it doesn't start at 1, that means you can't just look at the number on top and say what it is. Is it 8 minus 3, 5? No, it's not that either. I mean, just look at this. If I did 40 minus 1, I would get 39. That would not be 40 terms. It's always one more than you get if you subtract it. So if you get a summation which doesn't start at 1, you need to do 8 minus 3 plus 1. So that would be 6 terms. All right. So let's see. This one, the n is 40. The first term, when you plugged in n equals 1, you got negative 5. When you plug in the 40, you got a 40, 112. And then you just plug those three numbers into this. S40 equals 40 over 2 times negative 5 plus 112. S40 equals 20 times 107, which is 2140. What am I thinking there? Okay, for geometric, right? For geometric, we have a different formula for the sum of a finite geometric series. But what's in the formula are all things that we're familiar with already. It's got an A1 in it, first term. It's got an R, which is common ratio. So those are the things you've got to plug in to the formula for the finite geometric, the sum of a finite geometric series or sequence, whichever way you want to call it. Good. So let's use it. Okay. I don't like these problems. Okay, what is the sum? We're using this formula. We know the first term, right? The first term is this. Can we tell what the R is? This is the common ratio, right? What is the common ratio in this geometric sequence? It looks like you keep multiplying times 2, right? So the R equals 2. So that's what we'll plug in here. And then what's the last thing that we need? We need the n. How many terms are we adding up? And that was not given to us. So again, we're going to have to take this last term, right, and set it equal to, use this formula for an. An equals a1 r to the n minus 1. We're going to have to use that to figure out how many terms did we have in our sequence. The first term was 1. Or sorry, it was 3. The r was 2. And in this case, we know that we have the value of the term is 3072. So 3072 equals 3 times 2 to the n minus 1. Divide by 3. What is 3072 divided by 3? 1024. Okay, so we have 1024 equals 2 to the n minus 1. Okay, what power of 2 is 1024? Just think. You know, you're going to go from 2, just keep doubling 2. 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. I mean, if you keep doubling 2, sooner or later you're going to get there, right? This was 2 to the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. It was 2 to the 10th. So if 2 to the 10th equals 2 to the n minus 1, what's n? Ten equals n minus 1. What is n? 11. 11 minus 1 is 10. Right, so this is telling you that n equals 11. So now you know everything you need to plug in this formula. S11 equals A1 is 3 times 1 minus 2 to the 11th divided by 1 minus 2. Now that can be a little bit of trouble for the calculation. But remember, darn, I have to open that up. Remember that you could enter that in the calculator with the fraction format, and it would probably go a lot easier. Just a sec. So that's what we need to do. Let's put it in the calculator using the fraction format and see what we get. So we need to be here. Remember, alpha y equals 1 is the fraction format, and we're going to go 3 parentheses, 1 minus 2 raised to the 11th, get out of the exponent, end parenthesis, get down in the denominator, parenthesis, 1 minus 2. Actually, you don't even need parenthesis in the denominator, but that's okay. So does that look like that? More or less. So now you go enter 6141. How do you get what? You know, that's kind of a hard one right there. That's not normal. I didn't notice that that's the way their example is. They've really changed the book a lot since last year, but you know, that if you see how 2 to the 10th is 1024, if 2 to the 10th is 2 to the n minus 1, that means 10 equals n minus 1. Solve for n, add 1. You're going to get 11. Now, here's the thing to show you, because if we ended up having to do these calculations by hand or even with that formula in the calculator, we're going to create a lot of trouble for ourselves sometimes. But do this in your calculator, okay? Do alpha window, and notice the second option in there, alpha window 2. And you get the summation notation right there. So the truth is that if you're given a summation notation and just asked to find the sum, you can always do that. Right? So we would have to do this. For this particular one, I guess the difference here is we weren't given the summation notation, so we would have to come up with our formula. Our formula for this, for the a sub n, would be an equals 3 times 2 to the n minus 1. So if I put that in the calculator here, right, I'm going to say x equals 1 to 11, and then put in 3 times 2 raised to the x minus 1. Get out of that. Okay, that should be our sequence. Add them up, 6141. How do you get what? This? alpha window 2. You could also go to the math menu, go to math, and then go all the way to the bottom, and you see the summation is the 0 option. But there's a few things in this alpha window that you kind of like to know, right? The absolute value is right there, and the summation. Those are the main two. And actually the log base function, if you ever got asked to do a logarithm of a base that wasn't base 10 or ln. So you've got useful things right at the fingertips there. Okay. Now, if you're given a summation like this, and you have to use the formula, which again, this is something you could probably go pretty directly to that, what I just showed you in the calculator. But notice if I wanted to put this in the calculator, I would have to, or to use this formula. I need the A1, and I need the R, and I need the N. Okay, how many terms would there be if I started at n equals 0 and I ended at 20? It's not 20, right? Because that didn't start at 1. It's 21, right? Starting at 0, going, again, do the subtract. 20 minus 0 is 20 plus 1. So the n is 21. What is R? R is always the thing that's being raised to a power. So when you're looking at in this format, R is that. So R is 1/2. And the thing, if you have to do any work at all, it's to find the first term. And the first term you get by plugging in the lower limit. You know, what is 4 times 1/2 to the 0? Well, 1/2 to the 0 is 1. 4 times 1 is 4. So now you can plug everything into that. S, we just said S21 equals, first term was 4 times 1 minus 1/2 raised to the 21, 1 minus 1/2. But again, you know, if you're just asked for the summation, you know, given all of that, you put it in the calculator. That's probably what you would end up doing. Use that alpha window 2 and get that summation notation. Did anybody do that already? Try, see what you get on this one. This? Like what? Like this? Yes, that's what I'm saying. Do it. 2, right? X, and you can use N if you want. It doesn't matter, just as long as it's matching. So we've got 0, enter, or right arrow up to the 20. And then the formula is 4 times, and again, if you're going to use the 1/2, you're going to have to put it in parentheses. If you use 0.5, then you wouldn't have to. But I'm going to show it by doing that. 1 divided by 2 raised to the X. Right. Does that look the same? 4 times 1/2 raised to the X. 0 to 20. Enter. 7.9999. Sometimes when you get those, you could turn them back into fractions. Sometimes not. Math, enter, enter. And it doesn't. So that's the answer. Maybe you're going to round it to say 8. Right. I just say that this kind of calculation here, we have a lot of problems doing this if we just had to do it without the use of the calculator. Especially if, for example, that 1/2 was a negative, then you really end up having some trouble. You got to be really careful if there ended up being a negative there. Okay. No, we're not going to do that. Not going to do that. Okay. Now, okay, we already talked about how to do it with the calculator. Okay, let's do this one. Okay, put this in the calculator. N equals 1 to 5, 1/2 to the n minus 1. Where's my calculator? Yeah, do this first one. So alpha y equals 2. And now I'm going to put in x 1 to 5, 1, 5. And now go 1/2 parentheses 1 divided by 2 raised to the x. Okay, enter. 0.9675. Okay, let me write that down. Raised to the variable, right? Oh, sorry, you're right. I did that wrong, didn't I? It should have been an x minus 1. So let me go back. Second, enter, and I'll fix that. $1.9375. Okay, now try to do the next one. Only thing you're going to change now, make the number on top be a 6. What do you get? Remember, you can pull up the formula that you just did by going second, enter, and then just scroll back up over the 5 and make it a 6. Oops. Make that a 6. And what do you get? This one right here, right? Okay. So go ahead and try the next one. 1.96875. Somebody make it a 7 and see what you get. What'd you get, Nathan? 1.98, say again? 4375. Okay. And change it to an 8 and a 9 and a 10. See what happens to this numbers.
And I put in extra parentheses and it said error.
Is 1/2 to the x minus 1. Well, equals 1 to 7, 1/2 to the x. Is that an x and that's an x, or is one of those an n? Both x's and that's not working.
And I put extra parentheses. Well, you did it there in the error.
Yeah, I think that x minus 1 needs to be inside. You're like outside of the... You need to make it like this, inside the formula. That's where it goes like that. Then like that. Then raised to the x minus 1. And then we delete that. I probably got it messed up, but because it's still got that. Now try it. And that's math, enter. Oh, that is a decimal. If you do that math, you'll get the same decimal. Okay, what do you get for this one? What is the 8? Say 1.99211875. Right, the next one when you go to 9, 1.9960. 0375. What about the next one? 1.998. 046, etc. What does it look like these numbers are doing? They're getting closer and closer to 2, right? So in the end, you could make this number go infinitely high, and this sum is never going to be more than 2. It'll get infinitely close, but it's never going to get to 2. So you could actually do this. You could say the sum from n equals 1 to infinity of 1/2 to the n minus 1. And that would just be the number 2. So that's something that can happen with a geometric sequence that would never happen with an arithmetic, that sometimes you can add up an infinite geometric sequence and it will actually converge to a number. That's what they call it, converging to a number, right? And the thing is, if you try to do this in your calculator, there's no infinity symbol, right? So what you usually do, if you get an infinite sum, put in a number which is not too big. Put in a number, let's say like 50 on the top. Not too big, because if you put in, let's say you go, well, I'm going to put in 1 million. That'll be big enough, right? But the calculator will calculate forever. It takes it, 15 minutes to do 1 million. But if you do 50, you'll get the right answer, okay? So we will have to deal with infinite sums for geometric sequences sometimes. And if we do it with a calculator, where there's no infinity symbol, you just have to use a big number of some kind, but not too big. Right? The formula, if we use the formula, is this. It's actually a much simpler formula. And you can notice that the S now does not have a sub n anymore. Because it doesn't have that symbol, that's the infinite. On the formula sheet for the Algebra 2 SOL, it says this. It says S infinity. But it's the same thing. Now that doesn't always work, okay? There's a condition for which we can use this, and the condition is this, that the absolute value of R is less than 1. Meaning the terms have to be getting smaller. You can't be adding terms that keep getting bigger with each term, or else you would not converge to a sum. But as long as these terms are getting smaller, then it will converge to a sum. So terms are getting smaller, even if they're flipping sign. Oh, that's right. Today we're on that new schedule, aren't we? Golly. Yeah, so this class ought to be done at 55. Just what we need. Okay. So look at this sequence or series. Does it look like it's geometric? Does it look like you keep multiplying by something to get the next term? Yeah, it definitely does. What is the something you're multiplying by? Looks like that. So this is R equals 1/2. So does that meet the condition? Is the absolute value of R less than 1? Yes, it's 1/2, right? Since this is less than 1, then this will converge to a sum. Okay, what is the sum? The sum will be S equals A1 over 1 minus R. S equals 1, the first term, over 1 minus 1/2. That's the math. Right, so infinite geometric series. They will converge as long as the R is less than 1. And you could tell that because the terms are getting smaller. If you're given it in a list like that, I mean, that's what you're looking for. Or does it look like the terms are getting smaller? If you're given it in a summation notation like this, then again, where do you look for the R? It's whatever is being raised to a power. So what is the R in this case? -5/4. Is it less than, the absolute value less than 1? 5/4? No. So this one would not converge. Right? R equals -5/4. Right? The absolute value of -5/4 is greater than 1. So this does not converge. So if you get a problem like that, you just say, can't do it. Does not converge. Can't do it. Okay, which one of these here would not converge? because of the terms are getting bigger, or you can see that the R is greater than 1. Okay? The first one, 1/2, 3/4, 9/8, getting bigger, right? Terms getting bigger. Right, so there's no sum. Okay, how about this one? Are the terms getting smaller? 1/3, 1/9, 1/27. Okay, then try to use the formula. S equals 1 over 1 minus R to find the sum. How about this one? What is the R? It's whatever is being raised to the power, 2/3. So use the formula. And that was incorrect. That was supposed to be A1. So, did anybody get a sum?
Take away the add, I mean, subtract that, subtract that.
What's that?
It is subtracting the adding, subtracting that.
This here?
Yeah.
Well, what is that telling you? If the terms are alternating signs, what does that tell you about the value of R? It's negative, right? So what is the R in this one? What is negative 1/9 divided by positive 1/3? How is it that you divide by a fraction? You multiply by the reciprocal, right? So that's negative 3/9, which is negative 1/3. So the R is negative 1/3. That's what goes here. Anybody get a sum? S equals A1 1/3 divided by 1 minus negative 1/3. Right. 1/3. 1/3 divided by 1 minus negative 1/3 is 1 plus 1/3, which is 4/3. So this is 1/3 times 3/4, which is 1/4. And then the last one, if we're going to use the same formula, right? The thing about this one is you need to know the first term. How do you know what the first term in this sequence is? You plug in the lower limit. What is the first term? 2/3 to the 1 is 2/3. And what is the R? 2/3. 1 minus 2/3. So S equals 2/3 divided by 1/3. 2. Again, you could put that in the calculator. We could go like this. Second or alpha window 2. X equals 1. And then I keep doing that. 1. And then put in a number. I'll put in 20. That shouldn't be too high. You can't, there's no infinity symbol. So you just have to pick a number that's pretty high, but not ridiculously high. And then we'll put in this 2/3 to the x minus 1. And I'm going to use parentheses, 2 divided by 3 raised to the x minus 1. And then I have to end the parentheses. No, get out of that. Now notice that when you put up the summation notation, it gives you these parentheses, right? Your whole formula's got to get inside the parentheses. You can't put the x to the minus 1 outside of it, or else it would not work. So then hit enter. And, ooh, we got something wrong there, don't I? Oh, that's right. I keep doing that. So second, enter, scroll back over there. Yeah, it was just an X. Delete, delete, enter. 1.992. That's that. Again, if you get an infinite sum, there's no infinity symbol. Just put a number 20. I mean, I could have gone a little higher, maybe gotten it to go all the way to 2. But. Okay, so let's see. We're supposed to be able to distinguish between a sequence and a series, right? A sequence is the ordered list, a series is the sum. To use and interpret the summation notation, the sigma, and the rest.